Our next one is, where's the clicker? The commercial potential. And so for commercial potential, if you're thinking about going into this category, it's kind of targeted toward the business students, but anyone can do it in the Center for Entrepreneurship, and Michael even can help you kind of figure out what your financial potential is for all of this. And also great if you partner up with a business student if you're not in business already. On this one, does it have the ability to attract investors? Is the market large? Is the idea likely to be commercially viable? Is it trying to solve a big problem? That is there a big market out there for it? And one of the final questions the judges might ask is, would you buy this if you were in this market? And our speaker for this is Carolyn. She is the director of Doolittle. She and her husband have something like 27 patents, and they are working on a company called Guided Particle Systems. And she actually got called to DC, so she made a video that we are going to share with you. It's about 5 minutes.
Hi, I'm Carolyn, and I'm here to talk to you about Guided Particle Systems, Inc., based here in Pensacola, Florida. We are pioneering the area of free-form microfabrication. And before I get into too much detail about the company, let me kind of break things down a little bit. So if you take a look at our name, Guided Particle Systems, that really tells you a lot about what we plan on doing, or what we are doing, actually. So we are guiding particles or guiding material and developing systems and processes to do that, to be able to create free-form or non-planar or complex surfaced large area microstructures on certain features. If you take a look at microfabrication and the history of it, traditionally it's known most popularly for integrated circuits or the semiconductor industry. And then you go on into microelectromechanical systems. After that, you also had microfluidics, and all along the way you had printed circuit boards, which, as the integrated circuits got more complex and were able to hold more information, the circuit size on a standard printed circuit board became smaller and smaller, to the point that a lot of the traces on those circuit boards are in the micro scale, or less than 100 microns in size. Kind of taking a look at the history of printed circuit boards, the original planar circuit board started in the 1960s. Followed in the 1980s by a combination of a rigid circuit board plus a flex cable for rigid flex circuit boards in the 80s. And then in the 2000s, we had flexible electronics, or the introduction of flexible electronics. Since then, we've even gotten into the 2010s, where we're looking at stretchable flexible electronics. The interesting thing about the flexible and stretchable is when you want to actually take those materials and conform them to a surface, you're either distorting your pattern by stretching it, or you're distorting it by trying to lay it over a particular curved surface. So if you can imagine taking a piece of Glad wrap and wrapping it around the bowl bottom, you see areas where it overlaps and it crinkles and that sort of thing. And for certain circuits, you just can't do that type of thing. So what we're proposing as the future for a lot of things will be conformal circuit boards. And our free-form microfabrication technologies will enable you to have those conformal circuits. Now, whether this is eliminating parts where you may have some type of an RF shielding on a system, and now you're able to actually pattern and create that shielding directly onto your substrate, which may be the body of your part. Think airplanes for the military, ships, underwater vehicles. Anytime you want to integrate those circuits into the actual surface or body or construct of a particular machine, you'd be able to do that with our technology. So if you're familiar with 3D printing, you realize most 3D printers come in a box. So you essentially have a box that contains some type of XYZ and possibly theta stage, and then you attach some sort of a printer head, whether it's fused deposition modeling or inkjet or some other technology that's come out recently, to go ahead and create your 3D printed part. What makes our systems unique is that we're actually kind of taking it out of the box, and we're getting rid of the XYZ restrictions on size. So we are using a 6 degree of freedom industrial robot arm to be able to then put our end effectors on the end of that and be able to go over a large area complex surface, which you can't do with a traditional 3D printer very easily. So far, some customers that we're working with, we've been working about a year and a half now with Lockheed Martin out of Palmdale, California on a project. They have been our primary customer to date, and that has been on an RF shielding type application like I talked about earlier. And most recently, we run a Phase 1 Small Business Innovation Research contract through AFWorks, which is part of the Air Force. And we're working with them on doing some customer discovery for a quantum application. And then a third proposal that we just recently put out was with the DARPA and the Navy to be able to do some sensor actuator type technology. And we just put that proposal in last week, I believe it was, so it's going to be another month or two before we hear anything back from them. But we're pretty excited about the customers that we've had to date. So we were founded in 2016 as a Delaware corporation, when we do have our headquarters up here in Pensacola, like I mentioned earlier. And we're just really excited about the future and hope you agree we've got something exciting going on here in Pensacola.
Guided particle systems is going to be one of those Pensacola startups you'll be reading about for the years to come. The commercial potential here is you hear some of the key words, some of the key takeaways. It doesn't have to mean, super scientific. It just means it's going to make money and you understand some of that stuff.